Welcome to Team 19's instrument presentation. We'll be presenting 4 instruments to you today. The first is the Akara. This is a modern version of the traditional Middle Eastern one-string instrument. It has a collapsible design. It can be disassembled here and here into 3 different components: the resonator, the side arms, the tensioner. The instrument is traditionally played by squeezing the side arms. This newer edition is improved by instead varying the tension. Varying the tension of the tensioner instead of the side arms allows for larger variation of notes being played. Please reference slides 1 through 9 in the PowerPoint for AutoCAD pictures of my design. So the physics of fixed string length, but string tension variation. The cost, $13.50. Majority of the cost was for the sidearm material, and that's where the challenges were during the build, finding the right material that would have the right structure. Aluminum was tried, flat steel was tried, and we ended up settling on the slotted steel. Improvements, anything that can be made to the collapsible design as far as the hardware, these fasteners, the wing nuts, the eye bolts, anything that would, any variation of that would be an improvement to the design. My name is Sage. This is the Akara. I'll be handing you off to Quentin Shamsabadi. Thank you.
Sage. Next we have the Mbira. As you can see in slide 1, it's a percussion instrument that uses cantilever bars to produce vibration frequencies. Observe. It's quite compact and costs just over $10 to make using various household items. You can easily tune it by adjusting each bar like so. Originally it was to be bigger, but due to packing constraints and the cost of the right metals, I really condensed it down to size, if you'll compare my original to my finished product in slide 2. Overall, it turned out quite nice, aside from the stress over finding the metal that would flex and vibrate enough without sliding across the bridge when struck. If I had more time, though, I would have added or made a rounded resonator instead of a box to funnel all the sound together and make the tone much sharper. Throughout this entire process, I've learned a lot about frequencies and how little details can make a big difference when dealing with trying to be exact. But my biggest breakthrough was learning that any bar can vibrate, but to make an actual tone, it takes a lot of variables to get it just right. Now I'll pass the mic over to Mr. Nick Imlay.
Thanks, Quentin, for the introduction. My name is Nicholas Imlay, and this is the instrument that I built for our team project. It's called a dulcimer. It is played by pressing the string against the fretboard and by strumming the string. It is usually played on the lap or on a table. On slide 14, we have a picture of this instrument that I constructed. And then on slide 15, there's also a drawing. Slide 16 shows the important or unique features of the dulcimer. And the important features are that it is able to play the correct range of notes, and that it is also attractive. The unique features are that it's easy to tune, and then it also has a large soundboard. Slide 17, we have the physics for the dulcimer, and this is that the length of the string, as well as the tension and the mass, it creates the fundamental frequency. The area and the thickness of the soundboard affect the amplification of the sound. On slide 18, we can see that the changes to the design were made by changing the overall length of the instrument from 24 inches down to 23 inches. Instead of having 2 copper strings, we changed that to 1 bass guitar string. On slide 19, we see the final cost of the dulcimer is $9.97. And on slide 20, the challenges that were faced with building the dulcimer was the initial tuning of the instrument, and this was resolved by placing the instrument closer to the microphone. I will now turn the time over to Trevor Silvers, and thank you for your time.
Thanks, Nick. This is Trevor from Team 19, and I'm here to present the 4th and final instrument. The 4th instrument is the wind instrument. We were originally going to create the Dulcian, but due to careful consideration and problems in the prototyping phase, we had to abandon the project and go with one of our alternative designs, that being the panpipe. The panpipe was originally from the Andes region of Peru. It's a single open-ended wind instrument that is played by blowing over the top of the opening. When you blow across the top, the air is split at the edge of the pipe, creating resonant sound waves down to the bottom that come back out the top. This panpipe is made out of bamboo and electrical tape. As you can see, there's 2 strips of bamboo on the front and the back that are strapped with electrical tape, which gives it its rigidity. The pan pipe cost about $13.42 to make. It can be purchased, the materials can be purchased from any local hardware store. You can even grow the bamboo in your backyard. This particular pan pipe has 14 notes. They can be made with less or more. Now, a thing to note is that each pipe can only make one frequency. So you must make each specific pipe to a specific length in order to create said frequency. We'll give you a little demonstration on some notes. As you can see, plays nice, sounds nice. It's extremely lightweight. It's about 13 inches long by a foot wide and an inch deep. Therefore, it meets our criteria of fitting inside our 2 foot by 2 foot by 2 foot stage box with all of the other instruments with ease. It also utilizes less than 10 feet of pipe, which was one of our other requirements. So therefore, our criteria has been met on that. It cost under $15. We've meeting that criteria. Basically, it sounds great, lightweight, fits in the box. It meets all of the requirements and needs of our end user. You can find all of this information on our presentation slides 23 through 29. And we put a little song together for you. We hope you enjoy it. This is Trevor Silvers from Team 19. Here's the pan pipe, and we hope you have a great evening.